Okay, so 11, 12, we start to get into statistics. So your next strand test will be 7, 8 trigonometry, 9, 10 geometry, and then 11, 12 statistics. So the beginning of 11, 12 looks at ratios. So this really should just be a review of ratios. So remember that ratios we are comparing two items together, right? So we can write it as with a colon. So here I have a picture of 3 black circles and 2 white circles. So if I wrote that as a ratio of black to white, so we could write it in words, because remember that with ratios, order is important, right? So 3 to 2 is different from 2 to 3 in terms of what they represent. So black to white would be 3 to 2. If I were doing white to black, it would be 2 to 3. So order is important in what we're representing. So you can write it as a colon, right? You can write it in words, 3 to 2, or you can write it as a fraction, 3 over 2, right? So they all mean the same thing in terms of ratios. So here we have an example of 20 grade 12 students, and 6 said they were planning on returning for a 5th year. It wants us to write the ratio of returnees compared to total number of students, okay? So I'm going to write it out in words first. So I'll write returnees compared to total number of students, right? So I want to make sure I'm representing the proper items. So the number of returnees was 6, and the total number of grade 12 students is 20. So that would be the ratio representing that, or I could write it as a fraction. I could reduce it, so I could divide each side by 2 and put it in lowest terms, and that would mean the same thing, okay? So that is how we write a ratio. If there were 180 grade 12 students, how many would you expect to return for a 5th year? So this is using ratios to solve. So the ratio that we know is that the returnees to the total was 6 returnees out of 20 students. Okay, and we want to compare that, so that is equal, and this should be in the same ratio. 180 is the total. How many would you expect to return? So I'm going to use X for that. So X goes in the first spot, and 180 goes in the second. Okay, so you have to make sure you get them in the right order. So remember that 6 is the returnees, and 20 is the total. So when I write my other ratio, these should be in the same position. Right? So when I write my second ratio, they should be in the same position. So you can do it one of 2 ways. Let's fix this. So if I say 6 to 20 equals X to 180, I could say that times that should equal that times that. That should be in the same ratio. So I have to think, well, what would I multiply 20 by to get 180? I would have to multiply it by 9. So I would do the same to the 6. The 180 is 9 times bigger than the 20, so the X should be 9 times bigger than the 6. And so 6 times 9 is 54. So that's one way to do it. The other way is to write it as a fraction, and that might be easier. So I might say 6 over 20 equals X over 180. So I could write it like that and then cross multiply. Okay, so we do 20 times X equals 180 times 6. So 20 times X is 20X. 6 times 180, just let me grab my calculator, is 1080. And then I would have to divide by 20 to solve for X. And we get the same answer as 54. Okay, so you can solve ratios in one of two ways. You can figure out what did I multiply it by or divide and do the same to the other term, or you can do it as a fraction. One ratio equals the second ratio and then cross multiply. Okay, the next part of the unit is on mean, median, mode. So these are one variable statistics. You should be familiar with these from middle school. Is probably when you started to look at them. So mean is the average. So we just add up all the numbers and divide by how many numbers that we have. The median is the middle, so we'd have to put the numbers in order and then find the middle. And the mode is the most common value, and then the range is the difference between the largest and the smallest. So here's an example of some data. So we want to find the mean, the median, the mode, and the range. Okay, so the mean is the average. So we're going to take the total and divide by the number of terms. So how many terms are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 numbers. And then I just have to add up. Morning. I just have to add up these numbers to get a total. So that total adds up to 550. And then we would divide by 12 to get an average or a mean. Okay. All right, so that's the average. So get the total, add up all the numbers, total of 550, divide by how many numbers there are. There's 12, so I've just rounded it to 45.8. The median is the middle. So I'm going to put these numbers in order from smallest to largest, or you can do it from largest to smallest. So 28, so I usually just check them, make sure I got them all. 37, oh, no, I see a 33. So 33, 37. I think the next one's 40. Then we have 45, 46, 2 49s. 45, 46, 2 49s. And then we, oh, no, we have a 48. And then we have a, oh, no, I missed a 45. No, I got the 45, right? 45, just one of them. 45, 46, it's harder to see on the smartboard. 48, 49, 49. And then we have a 53, a 59, and a 63. So there's my 12 numbers in order. Okay, smallest to largest, and I want the middle number. So sometimes I cross them out. So I say smallest, biggest, smallest, biggest, smallest, and I just cross them out from end to end. And there are two middle numbers, right? So if you have an even number of terms, you're going to have two middle numbers, and so we're going to average the two middles. If there's only one, then that's your median. If there's two, then you're going to average them together. So we're going to take the average of 48 and 46, which would be 47. So that's my median. Okay, so depending on whether you have an odd or even number of terms, if it's an odd number, you'll have one middle number. If it's an even number, you'll have two, and then you just average it. Okay, the mode is the term I see the most often. Okay, so in this case, I see two 49s. So that is my mode, right? That's the term that appears the most. You can have more than one mode. You could have two modes, so it would be bimodal. So then you would just write them both down. Okay, and then the last thing is the range. So that's the difference between the smallest number and the largest number. So the largest number is 63. The smallest number is 28. Right, so it's just the difference between the largest term and the smallest term is 35. So that's the range. Okay, so that should all be reviewed. You should be familiar with all of that, mean, median, and mode. What term is the best one to use? So if you have a choice between mean, median, and mode, the median is the best choice to represent the data because it eliminates the effect that really large numbers or really small numbers would affect the average. So let's say you had a bunch of students in a class and everybody got around 60 or 70, but one person got 100 or one person got 20. That will throw off the average, right? It will make the average either go too high or too low, and it wouldn't be a good representation. So the median is a good representation, better than the average, because it eliminates the effect that really low numbers or really high numbers would have on the average. Not going to pull it up or pull it down. And then the mode isn't really representative of a good representation because it's just the most common. It doesn't really tell you anything about how everybody else did. Okay? So if they ask you what's the best representation, it's generally the median. Like if you're looking at a class average, I always look at the median mark, not the average mark. Okay, percentiles are shows you what percent of data lies below a number. So for example, if I said the median is the 50th percentile, it's because 50% of the data lie below, right? So if it's the 50th percentile, so let me fix this. So if you're in the 50th percentile, that means 50% of the data lies below and 50% lies above. So if Bob is in the 23rd percentile of intelligence, so here's Bob, he's in the 25th percentile, right? That means that 23% of people are less intelligent than him, and 77% of people are more intelligent than him. Okay, so that's what that means. So often when you're a baby and you go to the doctor, they will tell you what percentile you are in terms of height and weight. So when you go to the doctor and do your checkups, they might say you're in the 95th percentile. That means that you're heavier than 95% of babies your age. Or they might say you're in the 20th percentile. That means you weigh more than 20% of babies your age, but 80% of babies weigh more than you. Okay? So if we have the same set of data and we say what percentile is the number 59, okay? So here's 59. I've ordered them, right? There's 12 numbers, and 59 is the 11th number out of 12. So we're trying to figure out where it lies in this data. So it's the 11th number out of 12. So we would say 11 out of 12 times 100, because we want it as a percent. So 11 divided by 12 is 92% rounded, right? So 59 is in the 92nd percentile. So it's bigger than 92% of the numbers, okay? Anyone in the 25th percentile is considered young for their age. So what does that mean? Well, we want 25%. Let's write this as 25th percentile. So 25th percentile means that you are the 25th percent of those numbers. So we're going to do 25% of 12 numbers, right? Because that's how many the numbers are. So we want 25% of 12. So remember that 25% means 25 out of 100, or 0.25 out of 12 numbers would be the third number. Okay, so the 25th percentile would be the third number in the 12 numbers. So I go look at the numbers. Here's the third. So 37 years of age would be considered young, or younger would be considered young. All right, so I want to find the 25th percent of those 12 numbers. So I do 25% of 12 numbers would be the third number. And then I just look at my list. The third number is 37. So anybody who's 37 or younger would be considered young. Okay, now the last thing is quartiles. So quartiles basically means breaking the data into quarters, right? So 4 equal parts, and we call each one a quartile. So the first thing you do is find the middle. So I'm going to find the median. So I'm putting them in order. So these are all put in order. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So here's the middle. So this is the median, 47. And sometimes we call that the second quartile. All right, so the median is the middle, the second quartile. The lower quartile, or the first quartile, is half of these numbers, right? So that's going to be the lower. So I've got 6 numbers there. So here is the middle, right? So I have to average 37 plus 40 is going to be the middle of that. So we'll just add them up and divide by 2. Oops. So 38.5 is the lower quartile, or sometimes we call it the first quartile. Okay, and then 47 is the median, or the middle, or the second quartile. And then we do the same at the other end. So we went halfway between these two. So 49 plus 53 divided by 2 is 51. And this is the upper quartile, right? It's the quartile in the upper half of the numbers, or sometimes we call it the third quartile. Okay, so that's all you're doing for quartiles. You're putting them in order. You're going to find the middle, and then you're going to find the lower half, and then the upper half. So you've divided it into 4 equal parts, right? There's 1 quarter, 2 quarters, 3 quarters, 4 quarters. So each quartile contains 3 numbers. Okay, so find the middle. Then find the middle of the bottom half, and then find the middle of the top half. Those are your quartiles. Okay, so that's the first part of statistics. We'll look at applications later, but that will get you started on 11:12. So if you are behind in your tasks, you should be catching up.